Bloodstain pattern analysis.
Good day everyone. Today we will going to conduct a blood stain pattern analysis, and these are the materials that we are going to use. Manila paper, ruler and protractor, scientific calculator, spoon, beaker, distilled water, cup, Nescafe, scissors, adhesive tape, jubos, droppers, measuring tape, balloons, tissue, yarn, push pins, brush.
First, we put 5 ml of water in the beaker and added 6 pieces of jubos. Then mix after the jubos had dissolved. Then we added 6 pieces of Nescafe sticks. Each stick has 1.5 grams, but we still didn't get the perfect consistency. Then we add another Nescafe of 25 grams, 2 pieces. We mix it within 5 minutes, and after that, we get the perfect consistency of fake blood.
Part 1. Blood stain pattern. 1.1 passive blood pattern. Droplets.
There was 100 ml of blood in the dropper, and then we let it drip. We observed that every parent drop has a spine, and then there are satellite spatters in 3 parent drops.
Trail.
Using the dropper, we extracted 100 ml of blood, and we subsequently performed a trail blood pattern. We observed that it has a linear point of origin, a parent drop, and some satellite spatter.
Pool.
By using a balloon, we fill it with blood. Next, we use scissors to snip the balloon's edge. What we saw is that there are no spines or satellite spatters, and the blood is intact.
1 point to projected blood pattern. Low velocity.
Its point of origin appears to be straight, and each parent drop has many spines, whereas the other scattered parent drop has few spines, and the direction of this blood stain is from right to left.
High velocity.
Based on our observations, the blood stain flows from left to right and forms little parent spatters.
1.3 transfer contact blood pattern. Wipe. Swipe. Part 2. Illustration that depicts a blood. Spatter in its entirely.
Satellite spatter, a smaller droplets of blood that have detached from the main blood volume at the moment of impact, a blood that break off from the parent spatter when the blood hits a surface, a small secondary droplets. Parent drop, the droplet from which a satellite spatter originates. Spines connect with the main blood droplets. Also, it helps to determine the direction from which the blood traveled.
Part 3. Blood spatter on various surface. Rough surface.
In our observation, there are spines on the side, and then there are a lot of dots that scattered on the rough surface.
Smooth surface.
In our observation, there are only a few spines, and then there is a lot of finely dots.
Clothing.
What we observed was that the blood was absorbed by the cloth. Then in the center, there was the parent drop with spines, and then there were 2 satellite spatters on the cloth surface.
Part 4. Angle of impact.
She dripped blood as her first action. Then she used a ruler to measure the blood pattern's width and length. The first one's measured length is 1.7 cm and its measured width is 1.6 cm. A second blood pattern has measures of 1.7 cm by 1.5 cm. She used a scientific calculator to calculate the two blood stains. She had measured them in order to determine the outcome. The first blood pattern's result is 70 degree, and the second blood pattern we measured is similarly 70 degree.
Part B. Point of convergence.
The first step is to spread blood on the floor, then examine the stain to determine which blood stain has the perfect shape. Once the piece of blood stain was identified, we numbered it because it could only measure 20 of the blood stain. Next, we use adhesive tape and yarn to trace the point of origin. In the second step, we measure the blood stain separator's length and width using a ruler to determine its mass. Once we know the cm, we can solve for length and width using the formula. We also use a scientific calculator to determine the impact angle measurement. After solving, we measure the angle of impact of each 20 blood stain using a protractor to determine if the angle of impact is correct.
What is the importance of point of convergence?
The importance of convergence is that it can constrain how the blood stains were deposited on the surface and where they came from. Convergence in blood stain patterns is important for forensic analysis, as it helps determine the point of origin of the blood deposition, aiding in crime scene reconstruction and providing valuable evidence for solving crimes.